In this video, I am going to teach the problem part of 2D transformation. We know that the 2D transformation can be classified into basic transformations and other than basic transformation. The type of basic transformations are translation, scaling and rotation. And other than basic transformations, the important two transformations are reflections and shearing. First, I am going to discuss about translation. Translation is nothing but shifting the object from one part into another part. So the problem may be asked like this. In a problem, any primitive can be given. Here, the point is given. The point coordinate values are 2, 3 and the translation factor tx and ty values are 2. So first we explore the given value and we know the formula for translation, that is the new coordinate value x dash and y dash can be calculated from the previous x and y and added with this translation vectors. So apply the values in this equation, we can get this form. So x dash can be calculated as 4 and y dash can be calculated as 5. And finally, I visualize the output. Draw this rough graph and plot the dot in a given value, that is 2, 3. We are calculating the new coordinate value, that is 4, 5. So we are plot that dot here. So the original dot here, and after applying the translation, we can get the new location for this now. Let's move to the next problem. In this problem, they are giving the circle and we translate the circle into another location by using this translation factor, that is 5 and 1. So circle having the center point, here the center point is 1, 4. So we don't bother about the radius value. So first explore the given value. The point is 1, 4 and tx is 5 and ty is 1. Then apply this value in this formula. We can get the new coordinate value, that is 6, 5. So the new center for the circle is 6, 5. So after that, using this radius value, we can redraw the circle again. So we can get the translated circle. We need not bother about the individual pixels of the perimeter of the circle. So only we concentrate the center point of the circle. Now I try to visualize this output. Initially the center point of the circle here, that is 1, 4. Then after finding 6, 5, the center may be shifted here. I redraw the circle from these center points. So initially the circle resides in this point. Then after shifting, the circle is translated into the new position. Let's move to the third problem. In this problem, a triangle is given. So triangles means 3 coordinates are given and the translation vector values are 2 and 2. So we need to apply the formula for each vertex. For better understanding purpose, I draw the dot on a graph. Then I connect the vertices, I can get the triangle. Now I apply the translation formula for each vertices. First I apply the first point, that is 1, 1. So I can get the new coordinate value 3, 3. In the same way, I can apply this formula for all the vertices. So I can get the new value like this. From the collected value, I redraw the triangle again. Now I can get the triangle in a new location. So the original triangle is translated into the another position. In a examination for this translation problem, they can given any primitives. That means square, rectangle, circle or straight line or single dot, etc. You can identify the different coordinates and apply the formula for the each coordinate. You can get the new coordinate value and redraw the image. So in this way you can solve the translation problem in 2D transformation. Now we are moving to the next part, that is scaling. Scaling is nothing but increasing or decreasing the original image of the object. In this problem the object is triangle. So I redraw the triangle, it has its own coordinate values. And this is the scaling formula. Here the Sx and Sy are scaling factors. The given values are 2 and 2. So apply this formula for each vertex. In a first vertex A, the calculated values is 2, 2. In a second vertex, the calculated values are 6, 12. In a third vertex, the calculated values are 6, 2. So I find the new coordinate value and redraw the triangle. Now I can get the scaled version of, that is 2 times greater version of triangle. Here the scaling factors are greater than 1, so we can get the bigger image than the original image. Suppose the scaling factors are lesser than the 1, we can get the smaller image. Here the scaling factors are same, that is 2 and 2, so we can get the uniform scaling. Suppose if the scaling factors are different, you can get the differential scaling or non-uniform scaling. So using this method, you can scale any object in a 2D transformation. Let's we move to the next transformation called rotation. So rotation is nothing but the translating the object in a circular manner. So we need a angle and the pivot point. Here the pivot point is origin and the object coordinates. Here the object is single point. I try to visualize this problem. So 8, 3 may be reside in this location, that is called x, y. That can be rotated into counterclockwise direction like this. So the new coordinate value may be x dash and y dash. The rotation angle is 30 degree. And the new coordinate value can be calculated by this formula. So I apply this value into this formula. I can get this form. Using calculator, you can find the what is cos 30 and sin 30. Sin 30 is 0.5, cos 30 is 0.86. So apply this value in this formula. You can get this one, and after simplification you can get x dash equal to 5.38 and y dash equal to 6.58. After rounding off you can get 5, 7. I visualize this output in a graph. This is the given point that resides in 8, 3, and after rotation I can get 5, 7, and that can be shifted into the circular path 5, 7. So in this way you can solve any rotation problem for any given primitive. That may be rectangle, that may be triangle. You can apply this formula for all the vertices and get the new coordinate value and redraw it. You can get the rotated object. Then we move to the next part, that is called reflection. Reflection is nothing but taking the mirror image. It can categorized into 3 ways, that is taking the reflection by means of x-axis and taking the reflection by means of y-axis and taking the reflection by means of origin. First we saw the reflection about the x-axis. The primitive may be in any form. Here the primitive is straight line. It has the starting point as well as end point. And the problem may be asked like this. So apply the reflection in the given primitive and they provide the necessary coordinate values, that is 2, 2 and 6, 6, and mention the reflection about x-axis or y-axis or about the origin. In this question, the reflection about the x-axis. And this is the formula for finding the reflection about the x-axis. We keep the same x value for the new x coordinate and apply the negative value for the new y coordinate. So the 2, 2 can be converted into 2, minus 2. And 6, 6 can be converted into 6, minus 6. Now we redraw the image. We can get this straight line, that is exactly mirror illusion of the original image. Suppose the same value can be asked about the y-axis, means using this formula you can find the y-axis reflection. That means negative the previous x coordinate value and keep the same y coordinate value. Then we can get the reflection about the y-axis. Now the 2, 2 can be converted into minus 2, 2 and 6, 2 can be converted into minus 6, 6. Redraw the image in this pixel, you can get the reflection about the y-axis. Suppose in a question, the reflection about the origin means we can apply this formula, that is we can apply the negative values to both the x and y coordinate. So the 2, 2 can be converted into minus 2, 2 and 6, 6 can be converted into minus 6, 6. Then redraw the image, you can get the reflected image about the origin. So in this way you can achieve the reflection. Then we move to the last part called shearing. Shearing is nothing but distort the original image. Here the given object is triangle and the shearing parameter is 2 and 1. We can apply the shearing in the 2 different ways, that is by means of x-axis and means of y-axis. For x-axis, the formula for finding the new coordinate values is x dash equal to previous x value plus shearing factor into y coordinate value and keep the same value for the y coordinate value. So apply this formula for the first vertex. So we can get this value, that is 3 and 1. So repeat the same step for remaining vertices. So we can get this new values. So I explore the new calculated values along with the original value. Now I try to visualize the result in this graph. First I draw the original triangle by given values and draw the new triangle by calculated values. Now the original triangle is distorted, that is, we are apply the shearing operation successfully. So this is the shearing about the x-axis. Suppose in a question, the shearing can be applied in a y-axis means you can use this formula. Keep the x value as same and in y value, you can add the previous y value and multiply the shearing coordinate for y with previous x coordinate value. So apply this for each vertices, I can get the new coordinate values. Then I visualize the output. First I draw the original triangle using the given values and draw the new triangle after applying the shearing about y-axis. So in this way you can solve the shearing problem. Sometimes in your question paper, shearing can be asked by both x and y axis. So in that case you can find both the values for x and y axis and you illustrate the result like this. So in this way you can solve the shearing problems in 2D transformation. So I discussed all the transformation problems and I hope you can easily solve this in your examination. You should remember the formula for each transformation. So memorize this tabular column for solving any problem in a 2D transformation. Thank you.